Now, further continuing on the mechanical properties, we are going to take up the brittleness. So, in this property, the material which shows negligible plastic deformation before the fracture takes place. So, the material which shows negligible plastic deformation, that means the deformation is very much negligible on the plastic deformation. So directly it will go to be at the fracture takes place. The materials which exhibits this type of property, which is brittleness, is a cast iron, high carbon steel, concrete, stone, glass, and ceramic materials. So glass is an ideal brittle material in which stress strain curve in tension is essentially a straight line. For strength, the next one is we're going to talk about is the strength. It is defined as the ability of the material to resist the external forces causing various types of stresses without breaking or rupture. So it will be when the external load is applied on the material, those forces have been resisted, causing the various types of stresses. So without the breaking, which will or rupture. Based on the type of stresses induced by external loads, strength can be expressed as the tensile strength, then the compressive strength, or shear strength. So what does it mean? If I apply a tensile load on the material, so due to that, it will going to resist that external load. So it will going to induce us, since it is a tensile load which is applied, so naturally you will going to get the tensile strength. Similarly, if the compressive load is applied, then you will going to get the compressive strength. And if the shear load is applied, then it will going to get the shear strength. So the load required to cause maximum stress by the cross-sectional area of the test specimen is termed as the ultimate strength of the material. So what is the ultimate strength? So the maximum stress divided by the cross-sectional area of the test specimen, which are going to get the ultimate strength. Similarly, now we'll go for the stiffness or rigidity is defined as the ability to resist the deformation under the action of external load. So it is ability of the material to resist the deformation under the action of external load. So that is what is modulus of elasticity, is the measure of the stiffness. What is resilience? It is defined as the ability of the material to absorb energy when deformed elastically and to release this energy when unloaded. So it is the ability of the material to absorb the energy when it is deformed and when it is unloaded. So it will going to release that energy. So that is what is resilience. Resilience is measured by a quantity which is called as the modulus of resilience, which is the strain energy per unit volume within the elastic limit. It is represented by the area and the stress strain curve from the origin to the elastic limit point. So that is from origin, that is from O to E, which is the elastic limit. So within the area covered by this is the modulus of resilience. Now we're going to come with the toughness. It is defined as the ability of the material to absorb energy before the fracture takes place. It is measured by a quantity called modulus of toughness, which is the energy required per unit volume of the material to cause rupture under the action of gradually increasing tensile load. So this is the absorbed energy before the fracture takes place. Where is the fracture which is taking place? The fracture is taking place at this point. So this is what the area covered by this till to the fracture takes place. That is called the modulus of toughness, which is the energy required per unit volume of the material to cause rupture under the action of gradually increasing tensile load. Then comes with the malleability. It is defined as the ability of a material to deform to a greater extent before the sign of crack when it is subjected to compressive force. This property permits the material to be extended in all directions without rupture. This property has been utilized under forging or hot rolling and so on. Most commonly used material are lead, soft steel, wrought iron, copper, and aluminium. The next property what we can discuss here is on hardness. It is defined as the resistance of the material to penetration or the permanent deformation. It embraces many different properties such as resistance to wear, scratching, deformation, machinability, and so on. As hardness increases, the strength also increases. So this test of the hardness can be done by using the two tests, which is scratch test and indentation test. The scratch test consisting of pressing a loaded diamond into the surface of the specimen and pulling the diamond as to make a scratch. So indentation test consists of pressing a body of standard shape into the surface of test specimen. So example for the hardness is brittle hardness, Rockwell hardness test, and Bicker hardness test. The next one is the creep, which talks about the temperature. When a member or a part of a machine subjected to a constant stress at high temperature for a longer period of time, which is a constant stress at high temperature for a longer period of time, it will undergo a slow and permanent deformation, which is called creep. This property is considered for IC engines while designing in IC engines, boilers, and turbines. So in this will be completing our properties on the mechanical properties of the materials which we have been selecting for the design. If you like this video, please subscribe to my channel and give the feedback. Thank you.